Hello. Hello and welcome to the first 10 problems of permutations and combinations or combinatorics. So first few problems are going to be easy and I believe there are 526 questions. It will take a bit of time to finish all those, but I request you to watch videos in series. Even though you find problems are easy, please do them using pen and paper so that you get more and more uh, acquainted with the formulas and that you develop muscle memory. So two things, use pen and paper. And second is that when I'm stating the problem, you should pause the video and only look at the solution if you cannot solve the problem. Do not spend more than 15 minutes on a single problem. These are very easy questions to start with and should be able to do it easily. So without further ado, let's get started. First question says that if NP4 is equal to 360, find n. So by formula, we know that NP4 is equal to n into n minus 1 into n minus 2 into n minus 3, which is equal to 3 into 4 into 5 into 6 is equal to 360. So we observe that n is 6. The second question says that NP3 is equal to 9240, find n. So similarly, like previous question, NP3 would be n into n minus 1 into n minus 2 is equal to 9240. So it would be equal to 20 into 21 into 22. So how do we arrive at this? Okay, how do we arrive at 20, 21, 22? Okay. So by looking at this 0, we can be assured that either there is a multiple of 10 or there is a multiple of 5. Now this is 9, okay? So there are quite a few possibilities. It could be somewhere around maybe say 20, 21, 22. It could be 23, 24, 25. So a bit of trial and error if you do, you will be easily find the solution. Or it could be 25, 26, 27. So that way you enumerate and we get the result. Third question says that if 10 PR is equal to 720, find R. So 10 PR is equal to 720 is equal to 8, 9, 10. Okay, so R is equal to 3. Question 4 says that if 2n plus 1 pn minus 1 is to 2n minus 1 pn is equal to 3 is to 5, find n. So we write in expanded form. So the first one becomes 2n plus 1 factorial by n plus 2 factorial. The second one becomes 2n minus 1 factorial by n minus 1 factorial. Okay, there is no double minus. So from here we get that 2n plus 1 into 2n divided by n into n plus 1 into n plus 2. Okay, that is equal to 3 by 5. There should be a division sign here. It is not h2. So there is a division sign here. Is equal to 3 by 5. We get quadratic equation 3n square minus 11n minus 4 is equal to 0. So n is equal to 4n minus 1 by 3, but n is an integer, so n is equal to 4. Question 5 says that if NP4 is equal to 12 into NP2, find n. So we expand it, we get n into n minus 1 into n minus 2 into n minus 3 is equal to 12 into n minus 1, n into n minus 1. We cancel n in n and n minus 1, we get quadratic equation n square minus 5n minus 6. So n is equal to 6 or minus 1, but n is greater than 0, so n is equal to 6. Question 6 says that if NP5 is equal to 20 into NP3, find n. So like question 5, we expand it, we get n minus 3 into n minus 4 is equal to 20. And thus we have n is equal to 8 and minus 1, but n is greater than 0, so n is equal to 8 is the only solution. Now, next question is, if NP4 is to n plus 1 P4 is equal to 3 is to 4, find n. So this time it is written properly. We expand, we get n factorial by n minus 1 n minus 4 factorial. And this is n minus 3 factorial by n plus 1 factorial is equal to 3 by 4. So we get n minus 3 by n plus 1 is equal to 3 by 4. We solve it, you get n is equal to 15. Question 8 says that if 20 PR is equal to 6840, find R. So we can write 6840 as 18 into 9 into 20. So this gives us R is equal to 3. Question 9 says that if k plus 5p k plus 1 is equal to 11 into k minus 1 divided by 2 dot k plus 3pk, then find k. So we expand it, left hand side becomes k plus 5 into k plus 4 into k plus 3 and so on till 6, 5. Okay, 4 and all will be cancelled here because it will be k plus 5 factorial by 4 factorial. Okay, so right hand side becomes 11 into k minus 1 over 2 into k plus 3, k plus 2 up to 4. Okay, so we cancel out with k plus 5 and k plus 4 remain, which will be equal to 22k minus 22. Okay, this 4 and this 2 will cancel out. 4 will not cancel factors on this. So we bring everything to one side, we get k square minus 13k plus 42 is equal to 0, so k is equal to 6 and 7. Question 10 says that if 22pr plus 1 is to 20pr plus 2 is equal to 11 is to 52, find r. So expand it, we get 22 factorial by 21 mass r factorial into 18 mass r factorial by 20 factorial is equal to 11 by 54. We further expand, we get 21 minus r into 20 minus r into 19 minus r is equal to 42 into 52, which is equal to 12 into 13 into 14, which implies that r is equal to 7. So those were 10 very easy questions. If we look at the questions, then I believe till question 22, it will be very easy. After that, we have got real problems. Starting from 23, we have got real problems. So practice these on your own. Maybe I can go and maybe I can continue and do more problems. Let's see. So let's continue, okay? So if m plus n p2 is equal to 90 and m minus n p2 is equal to 30, find m and n. So we have m plus n p2 is equal to 90, that is m plus n into m plus n minus 1 is equal to 10 into 9. So m plus n is equal to 10. And m minus n p2 is equal to 30, so m minus n into multiplied by m minus n minus 1 is equal to 6 multiplied by 5, which implies that m minus n is equal to 6. So we have two equations, two unknowns, m is equal to 8, m is equal to 2. Question 12 says that if 12pr is equal to 11,880, find r. So we expand it, we get 9 into 10 into 11 into 12 is equal to, this left hand side is equal to 9 into 10 into 11 into 12. So r is equal to 4. So if you follow the problems in serial, it should not be a problem. Okay. Question 13 says that if 56pr plus 6 is to 54pr plus 3 is equal to 30,800 is to 1, find r. The 13 is also similar. We expand 56 factorial by 50 minus r factorial into 51 minus r factorial by 54 factorial is equal to 30,800. Now this left hand side becomes 56 into 51 into 51 minus r is equal to 30,800. Now 51 minus r is equal to 10. So r is equal to 41. Question 14 says that prove that 1p1 plus 2 into 2p2 plus 3 into 3p3 up to n into npn is equal to n plus 1 pn plus 1 minus 1. So we know that n into pn npn is equal to n into n factorial, which is equal to n plus 1 minus 1 into n factorial is equal to n plus 1 factorial minus n factorial. And similarly, n minus 1 p n minus 1 n minus 1 p n minus 1 will be equal to n factorial minus n minus 1 factorial and so on. So you see 2 into 2p2 is equal to 3 factorial minus 2 factorial. So add everything and you will get left hand side is equal to n plus 1 factorial minus 1 factorial, which is equal to n plus 1 p n plus 1 minus 1, which is right hand side. Question 15 says that if NC30 is equal to NC4, find n. So we have NC30, which is n factorial by 30 factorial into n minus 30 factorial is equal to n factorial by 4 factorial into n minus 1 factorial, 4 factorial. So n minus 30 is equal to 4 and n minus 4 is equal to 30. From both, we obtain n is equal to 34. So I'll stop here and I'll let you practice. So download the PDF. The link will be in the description. I'll show you how you can download the PDF and practice yourself. So head to my website ashtavat.org and you click this second link and you can download the PDF and study yourself. And then we have trigonometry book also. You can download that as well and study. I'm working on coordinate. I'm finishing straight lines right now. As soon as circles is completed, I'll upload it here and you can read that as well. Make sure that if you find mistakes, like I have mistake in this solution 4 here, fourth solution, the reciprocal is not written for this one. It should go to the bottom and -1 should come to top, and there should be no double minus. So if you find such mistakes in the book, please let me know in comments that in which chapter, in which problem, or what page number you have found the problem. Tell me what is the problem and I'll fix the PDF, because I don't have anybody to proofread the book. Okay, I am relying on you, the readers, to report the problems to me. Otherwise, whatever I observe while recording the video, that's what gets corrected. So I'll see you in the next video. Thanks a lot for watching and keep practicing. Enjoy.